So this is 3.4, extra practice for PVA. This is numbers 3 and 4. Number 3, it says a rock is dropped from an 850 foot tall building. Height is in feet and time is in seconds. So our position is going to be h of t is equal to negative 16t squared. That accounts for our gravity. It's plus 0t. Since it was dropped, the initial velocity is 0, and it's plus 850. We can find our velocity and our acceleration functions. V of t is just going to be negative 32t, and then a of t is just going to be negative 32. So these equations should be pretty straightforward. All right, letter B here says, so that would have been letter A. Letter B asks us to go through and find out when the rock hits the ground. So the ground is a position, so we're going to take our position function, negative 16t squared plus 850. We're going to set that equal to 0. The position of the ground is at 0. So when you do that, you end up with time is equal to 7.287 seconds. So that's when it hits the ground. They ask then, what is the impact velocity? So I'm going to take that 7.287, and I'm going to plug that into my velocity equation, since it's asking for my velocity now. So negative 32 times by that number is going to give me negative 233.184, and again, that's feet per second. So there are my two answers for section B. All right, section C here says, what is the total distance traveled by the rock? Well, if you just think about it, if you're 850 feet in the air, okay, on some tower or on a building maybe, you take it, here you are standing up there, all right, you have this object, whatever it is, and you drop it. So you take that object and you drop it. Well, if it started out 850 feet up here and ended up at 0, the answer is just 850 feet. Next problem, number 4. Number 4 says a rocket is shot vertically from the ground with initial velocity of 915 feet per second. So first, my position function, h of t is negative 16t squared. This is going to be positive 915. It was shot upward, t, and then technically plus 0. It's a plus 0 there because the initial position was from the ground, which is again 0. Velocity, negative 32t, plus 915, and then acceleration here is going to be just negative 32, as it always is. All right, so that would be there are the 3 equations there. Part A asks us to find the maximum height. Maximum height, you could technically take this original function, graph it, and find the maximum. Or remember, maximum height is just a turnaround point. Okay, maximum height is, since we're looking for the maximum, at the maximum you're not going up or down, you're at the very tippity top. The slope there is going to be 0. Slope is your derivative. Derivative here is the velocity. So we set our velocity equation, negative 32t plus 915 equal to 0. So again, derivative, velocity, maximum, all mean the same thing in these problems. So when I'm solving here for my time, it is just going to be equal to 28.594 seconds. So that's when it reaches my maximum height. Now, next question, letter B, stems right from that. It says, what is the maximum height? If you take this number, you plug it into position, so it's h of 28.594. Remember, you can use your calculator to do the shortcut with the bars, the y bars, if you want to, or you can just take this and plug it in. It's pretty simple, and you end up with 13,081.641 feet. Again, we're rounding to 3 decimal places. All right, letter C here is going to ask us to find out when the rocket hits the ground, okay, and then what is the impact velocity. So 2 pieces. So when does it hit the ground? So that's negative 16t squared plus 915t is equal to 0. Remember, it went from the ground, it's going to come back and hit the ground. Set that equal to 0, you can solve, you get time is equal to 57.188 seconds. So it was in the air for that long of a time. All right, and then the second piece of this, that's when it hits the ground. All right, the second piece here is saying what is the impact velocity. So I need to find the velocity at 57.188. Plug it into my velocity equation, and you end up with negative 915.016 feet per second. Now, if you remember, the impact velocity is going to be negative because it's coming down. Velocity, again, it dictates not only a speed, that's the 915, but also direction, that's a negative, it is coming down.